You ever stop and wonder what's really going on when you declare a variable in C? Behind the scenes. Turns out there's this whole set of secret rules, a hidden framework that decides where a variable lives, how long it survives, and who even gets to see it. And today, we're going to pull back the curtain on all of it.
Yep, we are diving deep into C storage classes. This is the key to understanding the secret life of your variables. Trust me, by the end of this, you are going to see your code in a completely new light.
So what are these rules? Well, they're called storage classes, and they are absolutely fundamental to controlling how your data behaves.
A storage class isn't just one thing, it's kind of like a bundle of properties. As you can see here, it tells the compiler four really important things about any variable. Its scope, which is where it's accessible, its lifetime, meaning how long it sticks around, where it's actually stored in memory, and what its default value is if you don't give it one.
Honestly, the best way to get a handle on all this is to think of them as four distinct personalities. Each one has its own job, its own quirks. So let's meet the team that's secretly running every single C program you write.
First up, we've got Auto. This is your everyday worker. It's the most common personality you're going to find. Pretty much the default for any variable you declare inside a function.
So let's check out its resume. Auto variables are local, which means they only exist inside their own little bubble, their own function or block of code. They start with a totally random garbage value unless you specifically initialize them. They live in standard RAM, and then, poof, they vanish the second their block of code is done executing. Now, here's the kicker. You almost never actually type the word auto. When you write something simple like int x equals 10 inside a function, the compiler just assumes you mean auto int x equals 10. It's the silent, hard-working default that just gets the job done.
All right, next up we have a personality with a really cool superpower, memory. Let's meet Static, the keeper of memories.
Okay, take a look at this profile. Just like Auto, its scope is local. It's stuck inside its function. But notice these two huge differences. Its default value is 0, not some random garbage, and its lifetime, it lasts until the entire program ends. It holds on to its value even after its function is finished running.
This right here is the perfect example. So imagine this, static int count is inside a function that you call over and over. Because count is static, it doesn't get reset to 0 every single time. It remembers its last value. So the first time you call it, count becomes 1. The second time, it picks right back up and becomes 2, and then 3, and so on. See? That's its superpower.
And now, let's talk about the one who's all about speed. Meet Register, the hopeful sprinter. This personality is basically an optimization request. It's you telling the compiler that you want a variable to be as fast as humanly possible. On paper, it looks a lot like our friend Auto, right? It's local, it starts with a garbage value, and it disappears at the end of its scope. But that memory location is the key difference. You are suggesting that the compiler store this variable directly in a super fast CPU register instead of the much slower RAM.
So, what's the catch? Well, it's just a hint. You're making a polite suggestion, not giving an order. The compiler can totally ignore you if there aren't any free registers, so it's really just an optimistic request for a little speed boost.
And this is a classic use case. For a variable like a loop counter that gets accessed constantly, telling the compiler, hey, maybe stick this in a register, could make that loop run just a little bit faster.
All right, finally, let's meet our fourth and final personality, Extern, the global ambassador. This one's entire job is about communication, sharing information across your whole project.
Look at its properties here, a global scope and a lifetime that lasts for the whole program. The extern keyword is basically a promise. It tells the compiler, hey, don't worry, this variable totally exists, it's just not here. You'll find the real definition somewhere else. Here's how that all shakes out. In one file, say main.c, you make the promise by declaring the variable with extern. You're just saying you plan to use it. Then, in another file, printvar.c, you provide the actual definition with its value. When you compile them together, the linker connects the promise in the first file to the reality in the second one. Pretty cool, right?
So there you have it, the 4 secret personalities that govern your variables. Let's bring the whole team together for one final review.
This table right here, this is your ultimate cheat sheet. Auto is your temporary local worker. Static is your local variable with a long-term memory. Register is your request for more speed. And Extern is your global connector for big projects. Seriously, understanding this table is the key to understanding how variables really behave in C.
At the end of the day, each of these personalities has a very specific job. Knowing when to use the everyday worker versus the keeper of memories, or when to call in the global ambassador, well, that's what separates good code from great code. So you've met the team. The only question left is, for your next project, which player are you going to choose?